So with these two problems, you'll need to know how to calculate things like y height and range. And so for example, let's say this first one, I give you an angle, say it's 30 degrees, I give you a speed, say it's 10 meters per second, and I want to know what is x, and I want to know what is y. And so the steps that you go through here, first, you find the time. Unless your time is given, that's almost always going to be your first step. And sometimes your time will be given, and we'll see some of those in the old tests. As you go through them, you'll see some of those as well, where you're actually given the time, and then you sort of skip that step or you approach it in a different way. So first you find the time. In order to do that, you say, well, the velocity in the y direction at the top, vy top, is equal to 0. And so then you can say vy equals v naught y plus ay t. Vy is 0, v naught y is 10 sine of 30. Ay is always negative 10. And then t top. And then you would solve that for t top. All right, so you'd have, this is equal to 5 minus 10 t top. So the time at the top of the trajectory is equal to a half a second. So that tells you that up here at the top, t is equal to 0.5 seconds. And that's a key piece of information that you'll need to know. And you might have that question. I might just ask you, what is the time at the top of the trajectory? Or I might ask you, what is the time over here? And, you know, that's going to be 1 second. It's going to be twice that total, twice the t top, because it begins and ends at the same point where it starts. Now, if I wanted to know what is y, I would say y is equal to v naught y t plus 1/2 ay t squared. And in both of these cases, you'd use t top. If you ever want to know the position at any point in the trajectory, you just need to know the time. So for example, if I told you the time here is 0.2 seconds, then you can figure out what is the y height just by putting in 0.2 seconds here. Because this tells us the position as a function of time. We can find the position at any particular time. What if it was at 1.3 seconds? Where would it be? It's going to be down below, right? I think you'll have a question like that on OpenStack. So it would be down here at 1.3 seconds because it's already passed up this 1 second point. All right, so if you're given the time, the problem's going to be considerably easier. But, you know, if you don't know how to do it, nothing's easy, right? So you really want to practice and make sure that you got the basics of how to work through these problems. So if I do this, it's going to be 5 times 0.5 minus half of negative 10 is 5. The negative comes about because ay is negative 10 times 0.5 squared. And so that's 2.5 minus 1.25 is 1.25 meters. And then if you want to know the x range, you say x is equal to v naught x times t. And remember that v naught x is the same as vx. Those two are the same. That comes about because from these equations, vx equals v naught x plus axt, that since ax is equal to 0, this whole thing goes away, and so vx is equal to v naught x. So I say vx equals vxt, and it's going to be vx. You might have a problem where I just ask you, what is the x component of the velocity? Hopefully that's a gimme. I would say 10 cosine of 30 times t. Well, gosh, what time do I use here to find the x range? I use 1 second. Because I want to know the position at this point, the x position. And so that would be 0.8 or 8.6 meters. Okay? Listen, a good practice for you on your tests is to, we'll come back to that second problem, but let me just, while I'm thinking of this, a good practice on your test, you get your bubble form. Can I go down from here? You get your bubble form. You know, you get that box in your bubble form. A good practice is to, as soon as you get your test, write down those equations. Y equals v naught y t plus 1/2 ay t squared. Vy equals v naught y plus AYT. And then you have the equations for the x too. X equals Vx t. And if you want to, you can remind yourself that V naught x is equal to Vx. Those are just our kinematics equations, but they're specific to projectile motion, taken AX equals 0 and AY is not 0. And then we have two other equations for chapter 4, and you might as well just go ahead and write those on there as well. The sum of the forces is equal to MA. Or if you want to be more specific, sum of the forces in the x direction is MAX. The sum of the forces in the y direction is MAY. And then there's one last formula, and that's all we had, is that the frictional force is mu times the normal force. And that's for static and kinetic. You just put an S or a K. So those are all the formulae that we have. But, I mean, as you know, it's applying those, and that's the difficult part. It's not, you all know these. I think almost all of you know these. But just be careful. I like to write them down. That way, as you're going through the test, you see them in front of you. And like students often, you know what they do? They'll leave out this T right here or whatever. I've seen so many students do that. But if you have it written down in front of you, then you don't make those mistakes as easily. Because, you know, in a test, it's just sort of, you're stressed and you're anxious and you're probably even a little bit tired. Just having that reminder is good for you. Okie dokie? So I'd love to see everybody do that. That's what I put that little box there for. You can write on your test, but just use that for writing those things down. Next test, you'll have an equation sheet, so you'll have that in front of you. We'll have a lot more equations. Okay, let's do that other one. And then we'll look at some old test questions for projectile motion, so you can see variations. You almost certainly have these, like I'm working here. You will have these that I'm working, one of each. But then you could have some other variations that are, we'll look at some examples like that. So, y'all did this in lab, where you shot the little metal bulb. You shot it out horizontally. So you'll want to look for keywords like that, like horizontal, or if no angle is mentioned, that means that Vx is equal to V naught. Or I could say V naught y is equal to 0 and V naught x is equal to V naught. That V naught, the initial velocity, only has an x component. Okay? Usually on these, I would give you the y height. I would say this is, say, 2 meters. And I would ask you for something like, what is x? So just like you did before, you have to find the time first. Here, to find the time, you just set, or you imagine, if I pick up something from 2 meters and drop it, how long does it take to fall? And so I say y equals V naught yt plus 1/2 AYT squared. V naught y is 0 because it's horizontal, so this whole thing goes away. And then y is 2 meters equals to -5 t squared. Oh, but now I have a problem, right? Because I have to make this negative. Actually, it's supposed to be negative. This is y equals 0. This is y equal -2. It's just how we set our coordinate system. If you forget that negative, you'll eventually try to take the square root of a negative number. That won't make any sense. So this is t is the square root of 2/5 seconds. Okay? And now, if you want to know the x range, that is the point over here, then you would say x is equal to Vx times t, which is Vx is whatever it is. Let's give it a value. Let's say that V naught is equal to 3 meters per second. So it'll be 3 meters per second times the square root of 2/5. I don't know what that is, but 1.9 meters. Okay, so I could give you that question as well. It's a two-step question. You have to find the time, and then you have to find the x range.
The only time I have t-top is whenever it's parabola starting at the bottom. So like you wouldn't square, or you wouldn't multiply that t bar to t-top.
You're right. Yeah, so t-top, we only double t-top when we start at the bottom and end at the bottom. Okay? I might give you some problems where you're not stopping at the bottom. If you look back at the old test And y'all had one in your open stacks, like one where it sort of stops, like I think it was a shell exploding on the mountain. You might have one like that, but on that, I would give you the time. Like, what is the time when it hits here? And I would ask you, what is the height or what is the range? If you know the time, these problems are not that complicated. Usually they're just one-step problems if you know the time. If you don't know the time, that's always going to be your first step. So when you come to those projectile motion problems, and they'll be all clumped together, because that's the way I do my tests, then look for the time. That's sort of your key thing. Don't forget to take your x and y components of your velocity. Make sure that you're looking, is it horizontal initially? In that case, the Vy is equal to 0 initially. Okay, let's look at some of the old tests. Do y'all have any particular ones that you want to look at? Any particular questions about projectile motion? No? I'm going kind of fast here, but if you want me to stop and slow down, I'm okay with that, okay? Alrighty? Alright. Let's look at, let's see, y'all have fall 15 in your workbook. Let's look at fall 16. Okay, here's number 1. That's a lot like the one that we just worked. Yep. Sorry, y'all don't have this, do you? Blow up a little bit. It says a projectile is launched with an initial velocity of 100 meters per second at 30 degrees. I'm not going to work through this one. I'm just showing it to y'all. Because it's just like the one that we worked. Oh, wait, no, that's not what I worked, actually. If I want to know the horizontal velocity of the projectile at the highest point in its path, how would I find that? How would I find the horizontal velocity of the projectile at the highest point in its path? And you might look at it and say, well, gosh, I don't know how to do that. But just stop and take a big, deep breath. And, if you don't know what to do, I always draw a picture. I'm starting here, going over here, and I want to know what is the velocity, the horizontal velocity, at the highest point in its path. What is V0? Well, then you think, oh, well, I know that it's the same as it is over here, because Vx doesn't change as it moves throughout the trajectory. And then you say, well, gosh, that's just the x component of the velocity. That's all he's asking. And Vx is equal to V0 cosine of the angle theta. So it's 100 cosine 30. So you can see questions like that, too, that are projectile motion, but they're sort of variations on what we've seen. And that would be 86.6. All right. Oh, well, this one's a little bit different too. You kick a soccer ball at an angle of 30 degrees. It travels a horizontal distance of 8.67 meters in 1 second. What is the magnitude of the ball's initial velocity? And you might not know right off how to work that problem. So you draw a picture. I know that it travels 8.67 meters. And I know that over here the time is equal to 1 second. I know that this angle is 30 degrees. And I want to know what is V0. That is, what is the initial velocity? Not in the x direction, not in the y direction, but the overall initial velocity. And so I'd first start and say, well, I can find out what Vx is. And Vx is 8.67 meters divided by 1 second. That comes from that equation, which you see on your sheet, would be x equals Vxt. And I solved that for Vx. And so this is 8.67. And then I know that Vx is also equal to V0 cosine theta. If you don't remember that right off, you might want to write that on your little square in your sheet too, so you have it in front of you. And I solved this for V0. So V0 is going to be Vx over cosine theta. 8.67. That's 0.867. Is that right? Yeah. And that's equal to, what, 10. So D would be the right answer. So you see, these are similar to those typical problems, but they're a little bit different. Um, this is just like the one that we did earlier, where I have an object that shoots off like this, and I'm just asking what is x equal to. Okay, you need to know how to do that. You're likely to, you shall see that. Oh, and here's the one, just like we did before. It shoots off at an angle, and I want to know what is x equal to. What is x equal to? You'll see very similar questions like this. You'll probably, I mean, 3 and 4, these two on the right-hand side, you'll see those for certain. They won't be the same numbers, but they'll be similar, and they'll be asking either, you know, what is the x range or what is the y range? And for the number 4, it'll be asking what is the x range? I'll give you the y height. Okay? So make for certain that you, okay? And then you'll have some that are variations, kind of like the number 1 and 2. Questions, John? Take a little breather. See my new coffee cup. Isn't it cool? It's called a brewnie. Like it has a little thing and you pour the hot water over the coffee grounds. It's fancy. Huh? I heard. It's National Coffee Day. Thank you. Okay, you'll see some conceptual stuff. Like for example, this one, which target will hit first? It's the target where the projectile has the lower y height. The y height tells how long it's in the air. There's some stuff here about just sort of the ideas from projectile motion. What is this? If you doubled the horizontal component, you know what? This was an OpenStax question. The students had it beforehand. I'm gonna skip over it. You will see some OpenStax questions. The height of the projectile when it's at the top of its maximum. Which of these is true? Vy is 0, right. Vy is 0 at the top of the trajectory. Yeah, Vy is 0. At the top, Vx is equal to V naught x, and Vy is equal to 0. You can see some graphs like this. Make sure you review those graphs. Like for example, this is the y component of the velocity. The y component of the velocity starts out big and positive. It goes to 0, and then it becomes big and negative. Goes up, stops, comes back down again. If I were to look at the x velocity versus time, the x velocity versus time would just be a straight line across. It's always constant. The x velocity doesn't change. Let's look at some others, see if we can find some other sort of sample problems. That's fall 16. Okay, here's one, number 3. This one's a little bit different. It's the horizontal problem. That is that I have, can y'all see, Akira, can you see the text on that okay? Number 3? Like super eyes or something. Alright, so a spring-loaded gun shoots a ball in the horizontal direction like this from a height of 20 meters. And I want to know, and it travels 3 meters in this direction. And I want to know what is its initial velocity. So you don't know the time, but this isn't one of those 2 typical problems we work. But since you don't know the time, that's going to be your first thing. You want to find the time. So how the heck are you going to find the time? Well, the y motion usually tells us, the y motion sets the time, and in this case we'll use the y motion to find the time. We'd say y is equal to v naught yt. V naught y is 0, by the way. That's 1/2 at squared. This goes away because v naught y is 0 because it's horizontal. Theta equals 0. I have negative 20 equals negative 5 times t squared. So t is equal to 2. So it takes me 2 seconds to travel 3 meters. I say x is equal to vxt. Vx is x divided by t. That's going to be 3/2. which is 1.5. So that's a good example of sort of variations on these. They're still similar problems, but they're just slight variations on what we've been doing. Okay? Any particular questions here, folks? Look, there's one. It's like that. Go up, down, same starting and finishing point. Oh, this asks the maximum height, not the range. How about this one, number 5? What is the direction of the velocity at point Y? What is the direction of the velocity? Well, at point X, the velocity is only in that direction because it only has an X component. At Y, it also has an X component, but it also has a Y component. And so the net velocity vector will be in this direction. So it would be B is the right answer. Okay? So sort of go through and make sure you understand what's physically happening. Sort of go through your notes, look through the concept tests. I'll pull some questions from those as well. And make sure that you can work those problems. There's some others here. All right, any other questions about projectile motion? We can move on to forces. Hannah.
For number 5, so the line was going the other way, and you were asking for the same question, it would be going in the opposite direction, right?
The other way.
Like, because I don't know how to word the question.
No, it's okay.
Like, if you draw the line going the other way, and you ask the same question, it would be opposite, right?
Yeah.
Because I just would show that it's going with the line, but the other.
Like this is what you mean, right?
Yeah.
Like if the projectile started up here and went in that direction. Yeah, at this point, the X velocity would be in that direction, and the Y velocity would look like that. You're right. It would be, well, that answer's not on there. Okay? All right. Close this. Is that okay? So a couple things that you should definitely expect on the test next week. And by the way, I know that some of you were anxious about moving the test up to a Friday instead of a Monday. But it is good. It means that I had planned to go into Chapter 5, but we're just not going to do that. We're not going to have Chapter 5 at all. And we're going to spend next week just bedding down and making sure that we got this stuff. Making sure that we got projectile motion and making sure that we got Newton's laws. So I think it is good for you. Let's look first at some 1D problems, and then we'll look at some 2D problems, because you're going to have both of those. You'll probably have 4 or 5 of each, 1 and 2D problems. 3 to 4 of each, 3 to 5 of each. The 1D problems, like for example, the elevator. All right, we worked this in the notes. If I have an elevator, and say the mass is, I don't know, 5 kilograms, and let's say that it's accelerating upward at a 3 meters per second squared, what is the tension in the rope? And so we go through the same process every time. I label all my forces. I have the tension in the rope. I have the weight of the block. That's all the forces I have. I don't really need to draw a coordinate system, but let's do it anyway. But FW, FT. Then, so this is first, this is second, third. Well, third I would resolve the vectors, but I don't need to do that here because they're already resolved. Fourth, I would write out the Newton's second law. Sum of the forces in the y direction equals MAY. Sum of the forces in the y direction, that's FT minus FW. That is the vector sum of those forces, equals MAY. And I'm looking for FT, so I solve it for FT. This one is more straightforward. There's just one step you have to take mathematically. Sometimes it's more than that. Sometimes there's 2 or 3 steps. So this is FW plus MAY. FW is 5 times 10. That's 5 kilograms, 10 meters per second squared, plus 5 times A, which is 3 meters per second squared. Notice that because it's up, A is positive. If it were down, A would be negative. And I wouldn't tell you that it's negative. You would just have to know that it's negative. Y'all follow me? All right. So that's going to be 50 plus 15. That's 65 newtons. So notice that since it's going up, the tension in the rope is more than the weight. If it were going down, the tension in the rope would be less than the weight. Because this acceleration would be negative, and it would be 50 minus 15, which would be 35. Okay? So be aware, too, that on the test, you'll have 65, you'll have 35, you'll also have 50, right? Because that's just the weight of the block. And then you probably just have some random number. Okay? So probably see something like that. Does it change if I add two masses? Let's just look at that. If you look at some of the old tests, you might see one like this. I probably wouldn't do this, but let's just sort of, what if I have this? What if I have a 2 kilogram and a 3 kilogram? Can you tell me what this tension is? Well, in the previous one, we found the tension to be 65. Do you think this would be less than 65, equal to 65, or greater than 65? In the previous problem, we had a 5 kilogram mass. Isn't that right? Wasn't it 5? Yeah. In the previous one, we had a 5 kilogram mass. And so what if I split it up into a 2 and a 3 kilogram? What's the tension going to be here? Is it going to be less, equal, or more than 65? It's going to be equal. It's like I can just imagine that these two masses are the same. All right, so the tension here will be equal to 65. I could just imagine that this is just one big 5 kilogram block. If I were to find the tension here, I would work it the same way, but just assuming that M is equal to 3 kilograms. That the 2 kilogram doesn't even affect that problem at all. Okay? You could see some other 1D problems. There was one in your book where you had the rocket, or in the OpenStats. That's sort of a rocket. It had the thrust going, and T was in this direction. Then we also had a force of like air resistance. It was like, I don't know, 600 newtons or whatever. And I wanted to know if this thing, which has a mass of 1,000 kilograms, y'all remember this question from the OpenStats? I think it's the one due tonight, right? And so if the mass is 1,000 kilograms and the acceleration is, I don't know, 20 meters per second squared, this isn't the numbers you had in your question, but it'll work the same. What is T? And in the book, actually, or in the OpenStats, you actually had 4 thrusters. And so you had to find 4T, and then you divided it by 4. Y'all understand what I'm saying? Let me work it out the way it is in the book. So in the book, or in the OpenStats, you had 4 individual rocket thrusters in the back of this thing. Each of them gave thrust T, a force T, and then you wanted to figure out what that T is. So here, we would draw our force diagram. Our force diagram has FA in this direction, equal to 600. In this direction, we have 4 times T. And then we would say the sum of the forces equals MA. That is 4T minus 600 equals 1,000 times 20. And then you would solve that for T. So that's what, 20,600 divided by 4. That's how you work that problem if you haven't worked it yet. I think most of you have. Okay? So that would be another type of 1D problem. Very likely to have a 2D problem. I mean, you shall have several 2D problems. You will also have an inclined plane problem. You're probably going to have 2 or probably 3 inclined plane problems. I'll probably split it up. One of the problems, because you know these things, there are several intermediate steps, and I'll probably split it up so that you get some of those intermediate steps. So let's say this angle is 30 degrees. I have a mass that is 4 kilograms. Let's say that it's stationary because of friction. And I want to know, oh no, let's say it's not stationary. Let's just say, what is the acceleration of this block? There's no friction. How fast does it accelerate? Would you know how to do that? That would be a good question. That's a nice standalone question. What is the acceleration of this block? Well, you go by the process. So you draw your coordinate systems like this. This one is actually a little bit different in the way I've drawn the inclined plane. I usually draw it the other direction. But I have my forces. That's Fw. Here's Fn. And that's all you got. Fw and Fn. Then I can redraw my coordinate system over here. And I'm going to go ahead and resolve my vectors while I'm doing this. I have Fn. And then I have Fw cosine 60 and Fw sine 60. Don't forget that on these inclined planes, only on the inclined plane, you can see some other 2D problems that are not inclined planes. I think we'll have time to look at them. But only on the inclined planes, you take the angle here is 90 minus this angle. And this angle is actually this angle right here. So you do 90 minus it to get it from the x-axis. Your life would be a lot easier if you do that. So Fw cosine 60 is the force in the x direction. So I'd say the sum of the forces in the x direction is actually negative Fw cosine 60. And that's equal to mass times acceleration. And then I would solve for the acceleration. So I would have negative 4 times 10 meters per second squared cosine of 60 equals to 4 times A. Notice that my masses cancel out. That it doesn't matter what your mass is. If there's no friction, they're always going to accelerate at the same rate. And so A is 10 cosine 60, which is A is negative 5. And the negative means, in this case, that it's going down the inclined plane. Usually this is obvious when you're looking at it, so like as far as the answer. Like obviously it's going to go down the inclined plane. But that's what that negative means. Okay? Let's look at some old tests. Yeah, Bree.
How will you remember to know like whether you should use Fw cosine 60 or Fw sine 60? No, I know that. I mean, like, why didn't you use Fw sine 60 instead of Fw cosine 60?
Right here, you mean?
Right.
I wanted to know how fast it was accelerating along the plane. And along the plane is my x-axis. So that's why I used the Fw cosine 60.
Because I feel like there's no problem with sine.
No, you shouldn't have ever had to use the y component to determine how fast it's accelerating. I think you're probably getting it mixed up with all the other signs that we use, right? And projectile motion and on an inclined plane. The reason it's on an inclined plane, it never travels in the y direction. Like we set up our coordinate system that way so that it never travels in the y direction. All right? Yeah. Tell me your name again, I forget. Kylie, right.
Oh, it's that's pretty good. Like, can you do a problem where you have to use the law?
The only reason you would ever use the y is to determine your normal force, which is if you have friction. We're going to look at one with friction. So yeah, the only reason you'd ever use that is if you have friction. Let's look at one. We'll pull up an old test, okay? Is that okay? Kylie. Oh look, there's the one from your opens test. That's a good question, don't you think? Friction. This one isn't good. Let's pull up a ball 15. I mean, those are good questions. I just didn't have an inclined plane with friction on it. That's what I'm looking for. Well, that one doesn't either, for goodness sake. These tests are good practice for y'all, okay? I really recommend that you go through them. These don't have friction either. You're probably going to have an inclined plane with friction, despite... Let me just make up one, okay? All right, so, like, let's say that I have an inclined plane. Say it is 30 degrees. I have a block that is 10 kilograms. I have a coefficient of kinetic friction that is 0.1, and I want to know how fast this block slides down the inclined plane. So the first thing I'll do, I'm going to draw my forces. I have my normal force, Fn. I have the kinetic frictional force, Fk. I have the weight. And that's all that I have. The next thing that I'll do is I'll draw my coordinate system. It'll look like that. I'll redraw it over here. And I'm going to go ahead and resolve my vectors. Now remember, this angle right here is 60 degrees. That's 90 minus 30. So now I'm going to go ahead and resolve my vectors. Fn is already on the y-axis. Fk is there. This is going to be Fw cosine 60. And then this is Fw sine of 60. Okay? So now I want to find out, I need to find what is the kinetic friction. What I'm looking for here is the acceleration of this block. What is the acceleration? And in order to do that, I'm going to consider the x function. Let's say the sum of the forces in the x is equal to m times a. But looking at this, while I know Fw, I don't know Fk. And so if you ever have a friction problem, you'll have one to two, couple better calculations. Then first I have to find the normal force. The normal force is not complicated to find. Most of the time well, as far as we're concerned, it will always be equal to the y component of the weight. You can have other forces interacting. Like I could have another force that's sort of pushing down on it, and that would change it, but we're not going to get into that level. But here, my normal force will equal to Fw sine 60. I say the sum of the forces in the y equals Fn minus Fw sine of 60. This is always equal to 0 for the inclined plane. So Fn is equal to Fw, which is 100 newtons. That's 10 kilograms times 10 times sine of 60. All right, so that's 87 newtons. That's the normal force. That allows me now to figure out the kinetic frictional force. Mu k times Fn, which is going to be 8.7 newtons. And now I can find the acceleration. I would say the sum of the forces in the x direction is max. That's going to be Fw cosine 60 minus Fk. And that's going to equal to mass times acceleration in the x direction. All right, almost done. And on the test, by the way, I'd break this problem into at least two separate problems. Like I might ask you, one of the problems might say, what is the kinetic friction on this object? And then the next problem would say, what is the acceleration of this object? So this would be 100 cosine 60, which is going to be 50. Let me write that out. minus 8.7 equals to 10 kilograms times AX. And I would solve that for AX. So that's 54.1 meters per second squared. Is that right? I think that's right. That's right. That's a good example of a 2D inclined plane problem with friction. Even though I haven't had it on the old test, I'm surprised by that. Like, you could see something like that. In fact, maybe that's a good reason to put it on this test, just to sort of get it out into the wealth of knowledge. Good job there. Okay? Y'all can do this. I know that you can. I know that it seems overwhelming, right? Some of you feel a little overwhelmed right now. You feel like you're in a hole, sort of, maybe, kind of. I know a lot of you are, that you feel a little overwhelmed, but you can certainly do this. Let's look at another 2D problem. This will be our last one. This one has been more common. I think we might have... Where is it? Oh, like this one. Here, number 25. This guy is pulling a block across the floor. And I want to know, what is the acceleration? I go through the same process. I draw my forces. I have a normal force up. I have a weight down. I have a friction, kinetic friction. There's my coefficient. And then I also have this force right here. Now, in this case, the normal force is not equal to the weight. Okay? The normal force is going to be more or less than the weight, because of that force of 50 newtons that the guy is pulling up. Is the normal force more or less than the weight? It's going to be less, because if I pull up on something, it's like I'm taking away some of the weight. It's not pushing down on the floor as much. So I will draw my coordinate system. I'm going to go and resolve my vectors, Fn, Fk, F cosine 30, that's that 50 newtons, and then F W, and then I have another vector up here. I would do it right there, F sine of 30. So there are two vectors pointing up in the y direction. And I want to know the acceleration of it. And so I would say the sum of the forces in the x direction equals F cosine 30. So far so good. I know all those numbers. F is 50 newtons. Minus Fk, but I don't know Fk. But I'm going to go and write mu k times Fn. Oh, but I don't know Fn either. So I need to find out what Fn is. And this is equal to ma. So separate, I need to find what Fn is. I look at the y motion, say Fn plus F sine 30 equals to Fw. I said the sum of the forces in the y direction is equal to 0. That is Fn plus F sine 30 minus Fw equals 0. And then I get to this. Because they're not moving, not accelerating in the y direction, those vectors have to be the same. And so I solve this for Fn, and I get it's 40 minus 50 sine 30. Oh, it's 15. Then I come back up here, and I say 50 cosine 30 minus 0.5 times 15 equals my mass, which is 4, times A. And I solve that for A. I get 8.9. This is probably the most difficult problem on this test. Alright, so if you feel overwhelmed, just take a big deep breath. Go back and start the simpler problems first. and then try to work up to these 2D problems where you have friction. In those, you get everything that we've done up until now. You get vectors, you get friction, you get Newton's laws, all that business all comes to head in these types of problems. The 2D problems with friction. But you'll have a couple of these, and so you want to get those right along with all the others. All right, people, are we done? Good. All right, we'll have another help session next time. And again, if you're online, you can come to class if you like. I'll record those sessions on Monday and Wednesday. But it's going to be sort of like this. Like, I feel like a lot of people need some good down in the trenches kind of work to master some of these things. So we're just going to sort of focus on this next week. All righty, you have a great day. Oh yeah, you need to sign in. Hold on just a second.